find the transpose of A. Transpose of A by interchanging the row and column. Transpose as usual. And then replace each element of A transpose by its cofactor. Okay, replace them by cofactor. We find the cofactor. How we find cofactor? Not remember. Okay, you can see here later. And then replace each element of A transpose by its cofactor. Then matrix is the adjoint A. So we write adjoint A. Then the inverse of A for the higher order. We will get 1 over determinant and adjoint of A. Okay, first, what should we do is, the idea is, we should to find determinant of A and adjoint A. It's a lot of work you need to do, of course. Alright, so first, we compute the cofactor. We will get this cofactor for the C11, C12, C12, C13, C21, C22, C23, C31, C32, C33. We put into the matrices and then we transpose them. We transpose this, so hence we get this is as a adjoint of the A.
Okay, I stop until this subtopic. So we start with finding the inverse of 3 by 3 or higher matrix by elementary row operation. So page 43. Okay, page 43. Find the inverse of 3 by 3. So to find what? To find the inverse. And one of inverse, what is one of the element which very important in matrices. So the inverse also give us a lot of information about that a lot of information about the matrices that we deal with. Okay. So this is one of the method to find elementary row. Before this, we use determinant to find by using cofactor method to find the inverse. So cofactor method we use the determinant to find the inverse. So we have another way, which is we call it as a elementary row operation. And then there is the basic way lah. You need to know the rules how to use elementary row operation. So elementary row operation, the process is from this theorem 3, matrix A. So matrix A, we have here matrix A. So we have this matrix A11, A12 until A14, and we organize it until A44. So what we'll have, this theorem should not have 4 actually. This should be N11, N12, and then there is until 1, 2, 3 until n numbers. Maybe we can stop at n numbers. Maybe we can stop at 10, or n we can stop at 12. It's up to the matrices. So A11, A10, and then so A2n here, not 4. N here. So that's why he give us n by n matrices. So the labeling here is wrong because we said as a n by n matrices, but for here they just put 4. Should be n, and we end with the n, a, n, n. Maksudnya meaning the element is n times m element, the total element, the number of element inside of these matrices. Okay. after we change matrix A. Okay, we change matrix A into this I. Okay, we change element into this I. So what we get, we will get the this position. Then by using ERO, so we find that A is a to the power of -1 is a inverse. Okay, that is like this. Actually it is like this. So we have, okay, we have a matrix A I, okay, at the first, and then he said that we use ERO to get I and A inverse. Okay, so now we have A is n by n matrices. Okay, so we have A11, A12, A13 until a number
A1N.
yes, A, good, A1N. Okay, close the bracket. Okay, so now we have A12 1, A2 2, A3 3 until
A23.
A2 2, no, until 2, A2 N, yes, until A2 N. Okay, so there is
at the A33.
yes, yes, something wrong here. Right, so 2 3 2n. So now until here the equation will be A3 1 and so on, and then until we have A n 1. Okay, A n 2, A n 3 until A n n. Okay, so 3 dot is meaning the continuous, 4 dot is no meaning. Okay, 3 dots. Okay, 3 dots meaning continuous. Okay, macam tu. Alright, so now he said we need to find the inverse here. Okay, so the inverse, okay, the inverse is 0 1 0 0 0 1 0 0 dot 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 1 0, sorry, by 1 until 1 n lah. Okay, so and then 0 1 0 dot 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 0. So 0, so we can see here the 0. Okay, the 1 will be the next here. Okay, 1 is the next here. So we write this like this. Okay, and then the 0 will be until 0 here, and then we have 0, 0, dot, 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 until 1 here. So we know that this is the identity. So once we use the ERO, so we use ERO, elementary row operation, what will happen, we will have 1, 0, 0, 0, dot, 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 0, 0, 1, 0, dot, 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 0, until 1, and then here is 0, 0, 0. We continue. Alright. So, okay, 1 minute. Kena kecilkan ni. So we have this. So from this position, from this position to this left hand side, and then the another number matrices here is we have maybe B11, B12, B13, dot, 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 B1n, B21, B22, B23, dot, 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 B2n. So B dot, 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 Bn1, Bn2, Bn3, dot, 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 Bn. So this is our inverse matrices. So this belongs to A inverse. Okay, after using the ERO. So how the process for the ERO? So we need to satisfy these 3 conditions. So it should be a square matrix. Okay, square matrix meaning the same matrices. If we have n by n matrix, so m ni meaning we have another number, so there is not a square matrix. So we need, if m
Did you record?
yeah, I'm recording here record my recording. But I not record in, maybe we can buat backup. Okay, we can backup. Because the resolution is not really good. Recording, start recording. Okay. So so you should have m by m. So for this dimension for the matrix cannot be used for the elementary row operation, but we just only accept m by m matrix, m or n by n matrix, meaning the same number lah. Okay, the same number. If 3 by 3, not 3 by 4, not, cannot. In this case cannot. Alright, 2 by 2, 5 by 5. We just have that kind of square matrix. Okay, the characteristic elementary row operation, we have interchange element. Okay, interchange maksudnya meaning we change the row, multiply ith row of the matrices by non-zero scalar. Okay, by non-zero scalar. Non-zero scalar meaning non-zero scalar meaning a value, a numbers. Maybe make sure maybe it's negative bi, negative 2 bi, 3 bi, something like that. Okay, that is a scalar, but not zero. So not zero. 0 kbi. So yang for this case, there is cannot be used. Add and subtract a constant multiple of ith row to the j row. Write by k plus bj or kb minus j. Meaning, what is the meaning of this thing? The meaning of this thing, add or subtract a constant multiply of ith row to the jth row. What the meaning here? The subtract only there is how can I see the example here? Make sure the negative, if you put one by one lah. You use one by one, actually it's more easier. And then after you put these matrices, and then we go to the bj. What I can say that maybe from your working, I can see but no, not all of you will do this mistake. I not remember how they do, but they didn't satisfy this law. And then look like what a right answer, a right method, but actually is wrong method actually. Okay, maybe later you can pass to me how to the best way to find this. Okay, this is one thing lah. It's very important, because the difference of this will give us a different answer. That is the main of this I row to the j rows. Okay, I cannot give you example here. I remember the mistake that you give us, previous student give us. I not remember, but okay, we can try that here. Okay. So by caution, you should put the first term here nothing, and then if you want to add, multiply or whatsoever, is the next term. If you see the first term is stand alone, the first row, and then we make the operation. That's the best method lah you need. If I see the problem is, if I see 1/2 R2, for example, plus 3 minus 3 R3, so the mistake is here. The problem you will give this will give a different answer actually at the end. That's the rules we talk here. That's the. So the caution, for the caution step, you just make sure in front is nothing, no operation in front. Okay, please make sure no operation in front, so that you get the right answer. Okay, so the idea, what is the idea of elementary row operation? The idea is, first of all, we need, actually they have idea here. We have idea here. First, make sure this will be 1. Okay, will be 1. After we make this one, and then there is first step. So tak boleh banyak. Okay, there is 1, step 1. This is step 1. Make sure this will be 1. Step 2. Okay, step 2. Step 2. Step 2 this. Okay, step 2. Make this 0. Step 2. So in this example, it's a good example lah, because they already have 1 0. So step 2 this 0. Step 3. Step 3. Make the A. Maybe I can put like this. Okay, maybe I can put like this. Okay. Okay, step 1. Okay, S lah only. S1. S1. A11. A11. Make sure 0. Make sure 1. Okay, 1. Okay, that is step 1. Okay, step 1. And then make sure 1. Second step. Okay, second step. A21. Make it 0. Make it 0. This is second one. Okay. Step 3. A22. Make it 1. Make it 1. This, like this. Okay. This. Okay. Step 4. Step 4. Okay, step 4. After step 4, we make sure this 0. This 0 or this 0. So step 4, maybe we can put step 3 is make A31 make it 0. We can also put this. That is optional lah. Because step 3 ni dia the step 3 is we can hold first. So step 4, we make this 1. Step 5. Step 5. Yeah. After this will be 1, make sure the below will be 0. So make it A32. A32. That is not A32. A22. N plus 2. 2 will be make it meaning make it 0. Make it 0 meaning the position below here should be 0, like this. Okay, so this position, and then make it this one. So actually this is the first. The rest is no need step. You just make sure we make it as a 0. But after we get this diagonal, you should find it by step, one by one. Okay, so we have six step. So we have n by n, n by n, make it 1. Make it 1. Okay, so the process is this here. Okay, make sure it will be 1. Okay. and then the rest is easier lah. Okay, just that's 3 step. So maybe we can find we can try this one. Okay, we can find try this one. Okay, we try this one. Okay, we try this one. So we have what we have a matrices A equals to -1, -1, -1, 4, 5, 0, 0, 1, 3. So okay, we see we have a step here. So okay, please make sure your mind please you need to save your time. So make sure this lecture make you already understand. You please do not postpone it. Please not think that okay I will record it and then you can see later. Please since you already allocate your time here, please make sure you understand in this lecture now. I want that type of thinking, that type of behavior, because if you go you find it this later, you waste your time. Actually, you waste your time in the lecture, and then later you need to allocate another time to understand. Okay, that's why in my lecture, if you not understand the step and so on, please make sure you ask not because of another thing, but you ask for your understanding. It's okay if you maybe you think it's very simple question, but there is the process will make you no need to spend time to my video, which is you do not need to repeat lah. Alright, that's make sure. I think a lot of you might buang masa, waste your time to repeating the same thing. So now you need to reduce your time to see to study. So you need to think how to reduce your time to study, to understand. That is the most important, because you have a lot of subject. Okay, so okay, from now here, okay, we have this matrix. So I already give you 6 step how to solve this. Okay, 6 step how to solve this. Okay, so first of all, first step is A11 should be 1. So now A11 kita, so this is can I put here in right? This is 11, A11, A12, A13, A21, A22, A23, A21, A31, A32, A33. Okay, so now A11 first step is make sure this is 1. So this is -1. So so we should have 1. So first we okay, so we have -1. Okay, we just copy first. -1, -1, 4, 5, 0, 0, 1, 3, and then we put the identity here. Identity is 0, 0, 0, and then we have 0, 1, 0, 0, 0, 1. So now If you want to, shut up. Okay, 1 minute. Okay. Okay, the idea here, we want to change this form into this form. Meaning, the identity should be here. Okay. So what should we do first? First step is A11 should be 1. Okay. So how to make A11 1? So we need to multiply -1 R row 1. Okay, row 1. Multiply the row 1. So okay, first we need to copy the rest 0, 0, 1, 3, 0, 1, 0, 0, 0, 1. Okay. Okay, just involve row 1. So we have 1, 1, 1, -1, -1, 0, 0. Okay. So the next is second step. What is second step? Second step is A21 make it 0. A21. So make sure this will be 0. A21. Second step is A21 will be 0. How to make this 0? Okay, how to make this 0? So we know that we can add. So we want change R2, row 2, right? Row 2. So row 2 we have 4. So 4 want to make 0. So we need to
Subtract 4.
subtract 4 R1. Okay? Okay, first of all, we want to change R2, so R2 we blank it. So another the rest row we just copy first, copy, and then 0, 1, 3, 0, 0, 1. Okay, the second row will be affected. Okay, the second row. Okay, the second row R2, so the is will be 0. Easy, right? So R2 5. Okay, R2 5. Okay, R2 5, and then -4 R1. R1 is 1. So equals to negative 1. 1. Okay, R2 0, -4 R1. -4 R1. So R1 is 1. So R1 is 1. So will be -4. So will be -4. Okay, -4. And then okay, 0 R2 0, -4, and then R1 is -1. We will get 4. So this is 4. So R2 1, -4 R1 0, so equals to 1. This is 0. Okay. Okay, settle for the first step, second step. Okay, then what should we do? We should make this will be 0. So we already have 0. So now 3, the third step the third step is A31 will be 0, so no need to make another changes. And then the fourth step is make sure A22 will be 1. So already 1. So go to the second step. A3 if we see the formula here, but I think for your level only involve 3 by 3 or 4 by 4. No need to further 3 by 3 lah. I think 3 by 3. So 2 plus 1 lah. 2 plus 1. 2 plus n. There is 2n plus 1. N 2 plus 1 here. Okay. Right. 2. So 3 by 2. 3 by 2 should be 0. So 3 by 2 should be 0. What should you do? Okay, you do. Okay, we want to change 3. Row 3. We want to be a 0, just minus R2. R2.
Make 3 to 0.
To make?
Subtract 1 to make 3 to 0.
Here.
No, the one below.
Okay.
Don't you want that to be 0?
Yeah, you want this will be 0, so we should minus this first row or second row?
Second row.
Second row. Why we do not minus first row?
Because it's complete. It met all the criteria.
Because if we minus first row, what will happen? This will be 1 minus 1. Okay, we try. So we can try here. This is the wrong. I just show the wrong way lah. Show the wrong way. Okay, 1 minute. Okay. So we will have. Okay. We want to change third row, so the rest element we just copy first. 0, 1, -4, and then -1, 4, 0, 0, 1, 0. Okay, so now if we put -1, so what will happen? R3 minus R1. So R3 minus R1 0 minus R1. R1 is 1. So we will get -1. R3 minus R3, so 1. So minus R1 minus 1 will be 0. Yes, we get this 0. But okay, 3 minus 1, so we get 2. So the problem is we need to change this again. So the problem there.
So if R1 was 0, we should subtract by R1, not R2. It depends on what's the right number to make the solution.
Yes, it depends. But the shortcut lah. So the shortcut is you put in this way. Meaning you need to use a few method here first. Because if not, some people if you can remember what your step is okay, but some people they confuse what should they do first. That's the problem in elementary row operation, ERO. So the best way you need to find what the first step you need to do for the to change what the position first you need to change. You need to to do it one by one. Okay, no, so if you skip that, there is a high chance to make a mistake. That's why I introduce you this step, because a lot of you will make a mistake because you confused. Sometimes some people they confused, they want to make this zero first. So there is the is you can do it, but it will take you a lot of time. That's will happen lah. So the shortcut here, you should just R3 minus R2. Okay, R3 minus R2. So what you have, R3 minus R2, 0 minus 0, 0, 1 minus 1 minus 1, 0, 3 minus, okay, 3 minus minus 4. So you have 7. Okay, 7. And then 0 minus 4, you have negative 4. 0 minus 1, negative 1. 1 minus 0, you get 1. Okay. If you can try, yes, there is depends on the situation, but usually what I'm once I look at your way to solve, some people get confused with what element first to make it 1 or 0. That the problem always happen there lah. Alright, so the next thing, the next is make this 1. Make this 1. So how to make this 1? Make this element 1. So R3, we want to change R3, divide by 7. So we will get, okay, first we just copy the other matrices, 0, 1, negative 4, 4, 1, 0, 0, 0, 1, okay, 1, and then negative 4 over 7, negative 1 over 7, 1 over 7. Okay. Okay. So now okay, now make this 0. Make this 0. So we want to change R2. So R2, we want to make it 0. So minus R2 plus 4R3. Plus 4R3. Because if you plus 4 at the row 1, R1, so this will give a value here. So if give a value, so we need to change again to make it 0. So and then we refer this because the rest already 0. So just deal with this one only, so that we can get 0 here. So what we will have, okay, we'll have, okay, first thing first, we want to change R2. So the row, another row, we just copy and paste. Okay, 0, 0, 1. I have no, I try how to, okay,
Doctor,
yes,
why are we divided by 7?
because we want to make a because we want to make a and n, make it as a 1. Make it as a 1 because here, if you can see here, if you can see here, before this, I already give you that I told you we have a I. So once we make the ERO to find the inverse, so it will be 1 A inverse. So now here you should make this like this. For 3 by 3, so if we have 3 by 3, 1 0 0 0 1 0 0 0 1, so and then we have a matrix here, and then we make the ERO, so what will happen, the I will change to the left hand side, so 1 1 0 0 0 1 0 0 0 1, so we will get A inverse here, inverse. Okay, this will so we can see here. Okay, we can see here, we want to that's why I cannot. Okay, so now from here, we already want the what, it already be a diagonal, so we just need, this will be 0 0 and 0. So I said that R2 we change, so another one, the rest we just copy first. Negative 4 over 7, negative 1 over 7, 1 over 7. Okay, so now R2 plus R3 kan. So we will be R2 plus 4 R3. So 0 plus 4 R3 0, so we get 0. R2 1 plus 4 R3 0, 1 plus 4 0, so we'll get 1. Okay, we get 1. So negative 4 plus 4 R3 is 1, so we get 0. And then we get negative 4 over 7 plus 4 R3 is 4, so you get the calculator, and then negative 1 over 7 plus what ni, plus 4 1, so you get the calculator, and then we get 1 over 7 plus what, 1 over 7 plus 4 R0, so we get 1 over 7. Okay, and the next step, you need to make this 0 and then this 0. Okay, that's all. So that is how to make this 0. So R3 minus R1, we want to change R1 minus R3, and then another one, we want R1 to change this element. Okay, this first and then this second. So R1 minus R2, you will get and then you will get the inverse of these matrices is here. You will get here this, like this inverse. You will get, okay, what will you get? You will get like this. Okay, so now okay, what you get, you will get, okay, you will get, okay, 1 0 0 0 1 0 0 0 1, and then you will get this answer, negative 15 over 7, negative 2 over 7, negative 5 over 7, 12 over 7, 3 over 7, 4 over 7, negative 4 over 7, negative 1 over 7, 1 over 7. So you can see in the whole picture, you already make this A we have A matrix and identity, and then we get this here, the left hand side identity, and then we get these matrices, which is these matrices represent A minus 1. Inverse lah, we call it as a inverse matrix. Right? Clear?
Yes, definitely.
Make sure make use this. Alright. Okay, so the most important here is write it clearly. Like clearly, so no, reduce the mistake. Alright? You will reduce the mistake. Okay, and then the most important here, A times A inverse is equals to what? Identity. Okay? Boleh?
Inshallah.
InsyaAllah. Boleh ya. Okay, A inverse. Okay, A inverse A times A matrix. A matrix A ni, A inverse equals to identity. So proof lah. How to prove? Prove it. So negative 1, negative 1, negative 1, 4, 5, 0, 0, 1, 3 times negative 15 7, negative 2 7, negative 5 7, 12 7, 3 7, 4 7, negative 4 7, negative 1 7, 1 7. Okay. Alright, so now how to multiply? Matrices is beautiful. We multiply this row with this row. First row, first column. Okay, first row, first column. You will get first row, first column, A11. First row, second column, you will get A. First row, second column, we get A12. First row, third column, you will get A13. Second row, second row, second row, first column, you will get second row, first column. Okay, second row, second row, second column, second row, second column, so you will get A. Second row, second column, we get A22. Second row, first column, A. Second row, first column, third column, A23. Third row, first column, A31. Third row, second column, A21. Third row, third column, A33. So A11. So A11, how to get A11? A11, negative 1 times negative 15 over 7 plus negative 1 times this element 12 over 7 plus negative 1 with the last element negative 4 over 7. So what you will get, put in the calculator, you will get 1. Okay, you get 1 here, 1 1 ini bahasa 1. Alright, A22, A12, first row, second column, first row, second column. So negative 1, negative 2 over 7 plus negative 1, this element with this element, so 3 over 7 plus I should put here A12 equals to negative 1, negative 2, 7 plus negative 1, 3 over 7. Okay, plus what? Negative 1 again, negative 1 with last element negative 1 over 7. Okay, okay, so this element, so there is 2 by 1, 2, so 2 second row, first column, second row, first column, we have 4 times negative 15 over 7. Okay, and then plus 5, 12 over 7. So here you will get 0. Okay, here 12 and then 0 plus 0, negative 4 over 7. So here you will get 0. Okay, second row, second column, you will have 4, negative 2 over 7 plus 5, 3 over 7 plus 5, second row, so 0, second column, so you will get negative 1 over 7 equals to 1. Okay, and then we need to find every element here. So A3 1. Okay, A3 1. Third row, first column, 0, negative 15 over 7 plus 1 times 12 over 7 plus 3. Okay, 3. 3 times negative 4 over 7 equals to 0. And then third column, third row, first column, second column, third row, second column, third row, okay, third row, second column, okay, second column here. So 0, negative 2 over 7, and then plus 1, 3 over 7 plus 3, negative 1 over 7. So here we will get 0, right? So the next is 1, 1. Kejap dia pening ah. Okay. Okay, I think you understand, right? You understand? Aish. Ni apa ni je? Apa dah jadi ni? Tak berjaya. Alright, tak berjaya. Okay. I think you understand what I mean. Okay. Okay. So meaning for multiplication A times A inverse we will get I. Okay. So for so we have element here A11. So we will get A11, A12, A13, A21, A22, A23, A31, A32, A33. So we multiply with A element. A element is B. B11, B12, B13, B21, B22, B23. So B31, B32, B33. So we multiply. If we want multiply, so what should we have? So for those elements, so we will have A11 times B11 plus A12 times B21 plus A13 times B31. Okay. And then another part here, if we want still the second element will be A21 first row, still first row, plus B21 B12 plus A22 multiply B22 plus A13. Sorry, here is A13. So A11, A12. So A11, A12, A13. Okay, and then multiply with B32. Macam tu lah. Alright. So this is another one. This is A11 plus everything, but the change is here. Okay. So A21 plus A22 plus A23, and then here the same element B11, B21, B31. Okay. Okay. You just complete this. So you will get what you will get. You will get 0. Sorry, 1. Okay, you get 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. Okay. That's all for today. So and then later we go to type of what this? Type of solution. So we later we will find we want to get to find the solution for these matrices, and then eigenvalue, eigenvector. By using to find the solution, we have a few methods: Gaussian elimination, Gaussian-Jordan elimination, Cramer's rules, and then we have eigenvalue and so on. Eigenvalue vector and eigenvector. So and then we finish this chapter. Next class we will finish the chapter. Alright. So that's all for today. Any question?